General Protocol Spaces. Banking on Freedom.
Yeah, sometimes lead somewhere.
Yeah, exactly.
So yeah, we've got a interesting space today. I think the main topic we're going to cover is going to be, our special guest has arrived. Let me get
Oh
him
my
over here if I
God.
can.
Is it really gonna be Mark?
Yeah,
Oh, I'm so excited. I haven't seen Mark in forever.
right? Me too.
Holy
So,
shit,
yeah, I
really?
think the
I
main
didn't know
topic-
about that.
That was my surprise for you guys. So I think the main topic's going to be scaling just in general, and of course some of the specific things people are working on. But yeah, we can cover whatever that is that's interesting. There's a lot within scaling to talk about, but then everybody also has their own projects and everything going on, so I'd like to cover as much as we can. While I've invited Mark up, we'll see if he is able to join up. But while we're waiting for that, Josh, could you give us a quick rundown on who you are and who Verde is and what you guys have been working on and what you do in general?
Yeah, sure. So I'm Josh Green, not to be confused with the other Josh, the lesser Josh, Ellithorpe, and then
Yeah, we're gonna fight that out later. It's gonna be great.
We'll see if he manages to wake up. But yeah.
yeah.
Hello.
Is he still on? He's still in Hawaii area? Is that where he's living these days?
No, I'm in Canada. I'm in Alberta, actually. Yeah.
Well, was that Mark? It sounded like it was
That's Mark. Yeah.
I was talking about. Oh, okay. Yeah.
That's Mark. Hey, Mark.
Mark. It's been a while.
Yeah. I'll let you guys.
But yeah. Oh well. Yeah. Sorry. I'm excited to see you, Mark. But anyway. So anyway, I'm Josh. I run Software Verde, and then I also wrote the Bitcoin Verde full node, and that's maintained by both me and Software Verde as a whole as well. We're actually just a custom software development shop. We've been around for quite a long time, 2011, and I've been in the Bitcoin world for almost the same amount of time, almost identically the same amount of time, give or take a few months. And yeah, I mean, I don't know what you want to hear about me. I mean, most people know who I am. Well, maybe not most, but some people know who I am. So
we're speaking to an audience of millions.
Yeah.
In a little bit. Yeah. So what have you guys been working on lately? I guess without getting into the depth of the scaling stuff, because we're going to definitely go into that. But
sure.
yeah, just what have you been working on?
I've been rewriting massive amounts of Bitcoin Verde. The previous implementation of Bitcoin Verde relied heavily on MariaDB or MySQL. And while that is really cool to do some things, it's not quite as performant as we want it to be. But more importantly, it has like this nasty socket bug where the database just kind of freezes when talking to Java. And that's not great for stability. It doesn't happen very often, but when it happens, it's really annoying. You have to like force kill the database, and it's awful. So we've been rewriting that, which is a very large undertaking. It's mostly done. In fact, actually, the Explorer pointing at bitcoinverde.org right now is running that new version slowly because the network code is not great right now. But that's the big undertaking we've been doing. Really looking forward to getting that released. And other things we've been doing that aren't Bitcoin Verde related or software development projects as a whole. We've got a really cool project that we hope to talk about soon that involves cash tokens, but not yet. So soon, maybe January. And yeah.
Does it maybe have anything to do with Dublin, Ohio? Maybe? No?
It doesn't have anything to do with Dublin, Ohio, but it does have to do with Ohio.
Oh,
yeah. So we'll see. And then
all right. I won't do 20 questions. Although I want to.
I know I want to too, but I shouldn't. So I won't.
Nice, very cool. Okay, thank you very much for the introduction. And of course, there's Mark who has joined us here. He's one of our heroes. I don't know how else to say it. He's done all kinds of amazing things in the history of Bitcoin Cash. Uh, so we could list those up. But he's also just a really great guy to know and a great guy to work with. So I really appreciate you joining us, Mark. It's very nice to hear your voice again.
Yeah, thanks for inviting me on. Yeah, I wish I could be helping out more with the Bitcoin Cash stuff, but yeah, just busy with the things. I won't go too much into it, but yeah, I always miss you guys for sure.
Oh, that's nice to hear. Yeah, it's yeah, life comes at you from every angle, and it'll be great if you ever have a chance to come back and keep working on things. I was actually thinking recently we've been talking a little bit about Cash Fusion in some channels. We might get to that if we run out of things to talk about on scaling.
For sure, yeah.
Wait, so
Did
wait,
you
so we should at least do some introduction of Mark, right?
go for it?
Okay. I'm gonna keep it really short. All right. He's known as the Cash Fusion guy. He's all
Take notes.
he's also the Acer guy, and he's he's you know in large part responsible for you guys not having to wait 2-3 hours for a confirmation these days. Yeah, and he's the guy I'm trying to find and beat up to get him to come back and work on BCHN among other things. So yeah.
Yes.
Yeah, you're not the only one who's trying to get me
Yes,
back in. For sure.
some of those other guys are I've been talking with some of those other guys, and it's a team effort. But yeah.
For sure.
We're trying various combinations of carrots. Yeah, and for anybody who's listening who doesn't know, the ACERT that Uname was talking about was the algorithm for adjusting the difficulty, right? The difficulty adjustment algorithm that allows a smooth 10-minute average block time that doesn't get impacted too much by swings in price and the concurrent swings in hash rate. So yes, thank you very much for that, among other things. And the thing I worked on with Mark, one of the things was back in the day was counting, what was it, SIG ops? Yeah, it was SIG ops, right? That was when we were doing the SIG ops counting.
Yeah. So back in the day, we did an upgrade with the changing the old SIG-ops rule to something called SIG checks, and that's sort of related to scaling, which is as I understand the topic of today. So we could touch on that at some point as it becomes relevant. But yeah,
it absolutely is. Yeah. So let's go ahead and get into that. What I wanted to do at first was kind of see how far apart or how close together all of us are. So this is an unscripted question for the most part, and I want to see, like how much distance there is between our opinions. So could each of you give us like a really short, your kind of top 3 to top 5 things that you think need to be done to reach 1 billion users, or 7 billion, whichever number you prefer. But like what are the big steps that we've got to hit to get there? And if you don't get to 1 billion, whatever it is, the next steps. But some of the top things that you think need to get done. Josh, could we start with you, since you've been working specifically on commitments and so forth?
Yeah, sure. I think there's 2 parts to that. There's the technology part, and then there's the people part. And personally, I think we're further along in the technology part than we are the people part. I think honestly, the best kind of software development is driven by demand. And I think right now what we need is just more demand. So facilitating things that create demand, being a useful currency and a stable currency, are important to that. And I think that's honestly the big thing that we need first. I think we need to have people using it and realizing what it's like and realizing why they're using it. That is more akin to the original version of Bitcoin when it was founded. realizing what's problematic with the current banking and credit card systems and realizing that there's a better alternative. Getting that awareness out there, I think, is number one. With that, will create demand. Also, things that create demand are the new technologies that we have, like NFTs. Cash tokens, I think, was a huge boon to Bitcoin Cash. And the utility that we can do. I know we had SLP previously, and there was a lot of demand that we wanted to do with SLP. Tokens are great. I think people are just starting to, like your average people are just starting to realize why they can be so great. I mean, look at ticket sales and how the realization that those can just be NFTs and they can be done better with NFTs. So realizing that and then getting that demand to drive the direction of technology is important. But then as far as we get to like concurrent transactions and just performance in general, I mean, we've made so many good strides. Bitcoin Cash has. BCHN is so great, and there's been a lot of research around the performance of the BCHN node. And honestly, I'm very confident that when the demand is high enough to start stressing BCHN and Bitcoin Cash as a whole, I think we're going to be very far along. I think right now we've got a lot of throughput capacity, and right now we just need to plan for the very long term and make sure that we're making intelligent decisions that facilitate the very long term while facilitating the demand of now. So.
Hey, you maintain a node too. It's not just BCHN.
Oh, of course. Yeah. That's why I'm rewriting the thing right now. That's, I mean, like the performance for Bitcoin Verde has been very good. Like, I mean, I'm actually very confident that we're going to be able to keep up. There's a lot of utility that multiple nodes offer, and I'm still very committed to that. I was trying not to use the word committed, but because we're talking about UTXO commitments later. But I mean, I'm personally very committed to making sure BCHNs or Bitcoin Verde is successful. I think it's got a lot of promise. I mean, we just talked about SIGOPS, and I think one of the underrated components of reworking the SIGOPS is honestly just node diversity. I know that change came around when Bitcoin Verde was just starting to look at one-for-one parity for how the legacy nodes did it, and the new version of SIGOPS was way more approachable. So that got us into parity without having to go through the arcane version of SIGOPS from the long ago. So I think like doing those kinds of things that really help diversify the network, really make sure that we are resilient from a technology perspective, but also a social perspective. We all have a very long and bruised history for Bitcoin Cash and all of the social problems that we've had. And I think we've really come together and we've learned a lot from that. And I think we have proven our resiliency for that. And I think we just need to make sure we don't forget the past and still drive forward. And I mean, I think we're doing a great job. There's been zero fighting in the last year plus, and that's been wonderful. So I'm really optimistic.
It's been kind of amazing. Yeah, it really has. That's great. Okay, so main points is there's the technical side of it, which we're going to talk a bit about today, which you work on also. Yeah, make no mistake, Josh is extremely technical. He made his own full node here from scratch. And then, but then the social side and yeah, driving demand. Absolutely. Once there's enough demand and there's enough things going on, that's going to create a kind of floor of support for infrastructure as well. It'll create demand and strain on infrastructure, but then also everybody's going to be aligned to make sure that infrastructure gets done and gets fixed up, right? So yeah, okay, very nice. Mark, did you have any thoughts? You know, you've kind of got some distance on things, maybe a little bit. Have you had any thoughts or have any current thoughts on where it is we should be going and the key steps that need to be done for scaling?
No, I think a lot of the conclusions were, analysis was, done back in the day. I'm not sure if there's much new. Like you mentioned, 1 billion users. Like, if you just wanted to imagine 1 billion transactions per day, I think that's like gigabyte blocks or something, right? For example.
Yes, it's getting up to that, or maybe tens
yeah.
of gigabytes. Yeah.
Yeah, maybe multiple
1.7,
transactions per person.
about
Yeah.
1.7.
Okay. Yeah. So, yeah, it's a lot. um, I mean, at that point, for as far as getting more users, that's one thing. But as far as handling that, that's technically, and having that capacity, yeah, that could be tough. Honestly, I haven't really thought about that specific scenario. So yeah, I don't have much to say except please look at the numbers.
Yeah, right. The real numbers, right? And that's actually a point that I think is that's at least on my list, is that you can't just do things in your head, right? There's been a lot of experiments. People have done setups where they make fake networks and see how propagation works, see how speed works. Uh, yeah, there's a lot of experimentation that has to go on to not just make sure that we can do what we're doing today, but make sure that we keep being able to do the next order of magnitude up, or a couple of orders of magnitude up on testnet. If I don't say on testnet, Uname's going to kill me. So do that on testnet. Yeah.
I mean,
All
the
right.
concept of scaling that high is also not something that we just do. You don't. No one scales from 0 to 1 billion.
Oh, yeah.
In a
You've
year.
got to get there.
Yeah, and I mean, part of the scaling process is evaluating the load as it increases.
Yes.
I mean, it's not like for instance, the type of transactions that get spent matter at that level of scale. I mean, they matter at this level of scale too, right? Like one of the coolest things that we've seen from analyzing how blocks are verified is keeping just like the last, I forget exactly the number, but I'll just arbitrarily pick a ballpark of like 10,000. If you keep the last 10,000 blocks worth of UTXOs in memory, you rarely have like a cache miss from that perspective, because most of the UTXOs that are getting spent nowadays are not terribly old. So when you're at that level of scale, is that still the same assumption? You know what I mean? Like, is that still the case? My guess is probably, but evaluating every incremental step of the way is kind of important to facilitating the required level of optimization to support that throughput. And I think that's why, we need to incrementally increase things and evaluate continuously, because the simple stuff of just how people are using the blockchain changes, and that changes how we can optimize things.
Yeah, and not prematurely optimizing, right? I mean, that's an obvious thing to say, but it's so easy to fall into, to get into fixing things up before it actually happens. Yeah. Okay, very nice. Jonathan, did you have any ideas or anything particular things to say about what needs what we need?
Yeah, so if we're going to go to 1 billion transactions per day, it's going to take a long while, and it's going to take up a lot of block space. So I took a quick look at this earlier, and I came to that number I just gave on 1.7 gigabyte blocks, but it wouldn't happen overnight. And with the upcoming dynamic block size chip, if that takes effect, then we're looking at somewhere between 7 and 10 years to reach that if we are successful in driving demand. And we're unlikely to be that successful to drive demand, so it's probably going to take even longer to get there. But I think most of all the scaling things we need to do have already been done now. And I see UTXO commitments or some scheme to bootstrap a node and allow validators to kind of forget the past is the missing thing before we can actually say that it's perfectly safe to have like multi-gigabyte blocks.
Hey, sorry, I was muted. Thanks. Yeah, good deal. Uname?
Yeah, I just want to elaborate a bit on the upcoming adaptive block size proposal. Well, I mean, it's not really a proposal anymore. It's been implemented and it's in the final sprint. But I just want to talk about it a bit. The main focus of the the main reason it exists is not that okay, we put an adaptive block size algorithm in place and everything is going to be solved according to the schedule. Like, okay, we're gonna reach 1.7 gigabyte blocks in 7 years or something like that, and in that many number of years, everything is going to be magically solved. That is not the case. We still have a lot of things to do in the meantime. The main purpose of that upgrade is is to have a explicit algorithm to follow, so that I think we emphasize this over many times over a few spaces, but it's worth emphasizing again to give people confidence, to tell people, okay, this is what we're committed to do according to this algorithm, and there's going to be a lot of inertia if anyone wants to change this, so that people can rest easy and say that okay, it's not going to be magically solved, but it's solvable, and when the time comes, it will be there will not we won't need to have a huge fight and destroy everything in order to get there, like what happened in the beginning of BCH. So that's the relationship between this adaptive block size proposal and scaling. We still need to do work on scaling, a lot of work. But we can do so confidently on the way there.
And not only confidently, but there's a predictability and stability element too, right? Which is something we value greatly given our history. Yes. The predictability is that the limit grows at a certain rate, even assuming maximum demand. So that gives a point that you have made very well many times. That gives users, infrastructure, and businesses, nodes, etc., all the stakeholders in BCH, it gives them time to look ahead and say, okay, so in the absolute worst case,
yes,
this is what I have to build for.
Yes.
That's a huge gain,
yeah,
for this adaptive block size.
Yeah, and having confidence means investment, and that investment is both in usage and development resources and also money, and that in turn fuels any scaling challenges that we'll face. So
Right. Yeah. I always appreciate how visionary you guys are on thinking ahead and making sure we get the big obvious things done.
Well, I mean, it's not really us being visionary. Like BCH is the only coin to be tested by fire so much. So
we've been through a lot of fire. This is true. I was just thinking, besides the visionary stuff, we've also been running into all the little details of infrastructure scaling. You're using a wallet, and whatever app you're using just happens to have like thousands of outputs, thousands of coins in your wallet, and then it's like,
oh yeah,
shit, the software wasn't built to handle that. It's like sending 1,000 network calls out in parallel or something. It's like, no, okay, that doesn't work. There's a lot of little things to do as well.
Yeah. It's not even the network. Our wallets are shit at this. We need to scale them. That's like the most immediate thing that we need to do. Like, holy shit.
Yeah. So it'll come in steps, and like Josh said, with the demand of users. So having said all that, that's very cool. Thank you, everyone. So Josh, could you tell us at a high level, for a general audience first, what is the UTXO commitments you're working for? And like, for example, Jonathan also said that's extremely important to get done. So what is that, and why is it important?
Yeah, I mean, so UTXOs, as we sync a blockchain, are like the cumulative state, right? So if you spend a transaction, or if you create a transaction and then you spend those outputs, you can think of that as, and so you say you create a transaction, it creates 2 outputs, you spend both those outputs again and create 2 more outputs, and then spend those 2 outputs again and create 2 new outputs. those are like 4 or 5 transactions, but the actual difference in the UTXO set hasn't really changed. You started with two UTXO sets and you ended with 2 UTXOs. So you can think of it as just the end result of all of the calculations that have happened on the blockchain to that point. And as you might imagine, that end result is smaller than the entire history. So as we're getting more and more transactions, we're getting more and more throughput, and we're doing all these calculations, and then all we really need to know to validate the next transaction is, well, do those UTXOs exist, and are they valid, and can you spend them? So that's what Jonathan was talking about a second ago about getting a node online. To get a node online, you just really need the UTXO state. You need the current state of the network and what UTXOs are spendable.
Right. I just for people who are listening, there's 2 analogies I've heard that are pretty good. One of them is the UTXO set is like the idea of all the people that are alive today, and all the people that have died in the past. They were also important, but they're to some degree less important than knowing all the people that are alive today. So that's kind of one analogy. And then the other is all the money that's in everybody's wallet right now in the world. How much money and how many coins are in your pocket right now versus where has that bill been throughout its history. That's also maybe interesting, but it's less important than where the money is right now. So those 2 analogies kind of give the concept of what kind of information we have to have. Is that fair? Did I get that right? Are those analogies okay?
I think that's fine. I mean, it's the same thing as going into your traditional bank account and seeing what your current balance is versus asking your bank, hey, what were all the transactions I did for the last 50 years?
Yeah.
It's
I'd like
it's how much money do I have?
I'd like to jump in and say that I believe it's worth pointing out that these things are different problems to be solved by different actors. Your bank might need to provide your full history to you, but they don't need to provide your full history in order to show another bank that they can send money to that bank. So the UTXO set and bootstrapping a new node, I specifically said a validating node earlier, because that's the part that I think is valuable for the decentralization aspect of the network.
I agree with everything you just said. There are different roles that a node can play, and just like Jonathan said, whether or not I can spend this money requires an updated UTXO set. It does not require the entire history of the blockchain, and that translates to real use applications like your wallet. So if you if you try to load up your wallet on your phone, there's a difference between seeing all of your past transactions and then just seeing the ones that you can spend currently. That is a consideration that might end up providing good scalability in the future. Right now, when you load up your wallet, if your keys are old and you've got a bunch of transactions in there, you're probably going to see all of your old transactions, and that can be valuable. That's actually something that you can't really even do with your traditional bank account. Like normally, they don't go past 2 or 3 years worth of history, but Bitcoin right now, Bitcoin Cash, you can see all of them as long as you have the keys. And that's really like the fundamental difference that we're kind of talking about. It's how much history are we making available? If you go on a block explorer, you're exploring the entire history. But if you're a miner, if you're validating transactions and creating new blocks, you don't actually need that history. You just need the current valid state. But you need to know that the valid state is valid. That's why we talk about UTXO commitments and not just fast sync. But yeah.
What's the difference there? So in the context of, we need to scale, what are those 2 things, the fast sync and the UTXO commitments? What's the difference here? And what's the value of them?
Yeah. So fast syncing is a term that I stole from, I think, BCHD, but I think they might have also stolen it or borrowed it from somebody else as well. But regardless,
This is the way.
syncing, yeah, this is the way. So fast syncing is really just taking the state of the blockchain at a particular block height and then downloading all of the UTXOs for that older state. So say I wanted to fast sync to a month ago. All I need to do is download all of the UTXOs that were valid a month ago. And then from there, I can start syncing the blockchain normally to be up to date. That's a lot faster because the state, like the UTXO cumulative state is like, I don't know, like 2 gigs or something like that. I should check real fast, but it's tiny. It might be 10. But the whole blockchain is like 170 if you compress it. So it's obviously a lot faster to download. It also just requires substantially less amount of computing power because you just have the state in front of you. You don't have to derive the state from literally years of transactions. So you can come online with fast syncing in I mean, Bitcoin Verde, if you fast sync a Bitcoin Verde node, you're up in, I think it was like 4 hours or something like that. Versus Bitcoin Verde, I think it was like 24 for the previous version. So it's substantially faster, but that is you trusting that the UTXO state that you got is accurate and that someone or something didn't omit UTXOs or add UTXOs that never were actually created. So it's important that you as a user for a mining node, and then also you as a wallet user, know that the UTXOs that you're receiving are real and that they're going to be agreed upon with anybody else that synced the blockchain traditionally. And that's where the commitments part of UTXO commitments come in. So a proposed addition to fast sync, so basically UTXO commitments require in some ways the concept of fast syncing. The purpose behind them is to enable trustless or significantly reduced trust at a practical level, fast syncing. So the difference for commitments is that commitment is actually getting added to the block when that block is getting created, which means that if that miner decides to lie when they create that UTXO commitment, then their block is invalid and they're going to lose the money that they've spent creating that block. And somebody else is an honest node is going to pick that up and then mine their own block and collect their own reward. Which is kind of a fundamental trust model that we have in Bitcoin Cash in general, and also Bitcoin. Like that's just a fundamental concept that we have. So that's the difference between fast syncing and UTXO commitments. UTXO commitments are actually making it a part of the rules that make a block valid, and fast syncing is the benefit that you get from having a UTXO commitment.
Great. And the reason this is, I mean, let's see, more like a practical framing of the usefulness of it is like the first thing that comes to mind for me is, I'm a business and I want to run a node because I want to make sure to have my own connection to the network, or I want to have a private connection to the network, or whatever it is. And in some distant future, starting up a node, if you don't have any of these things, fast sync, the UTXO commitments, then I've literally got to go back to the Genesis block 0, and sync all of history since the beginning of 2009 when Bitcoin started up to today. And that is a significant amount of resources of all kinds to get to that point: time, money, computing power, etc. Is that fair? But then with this, you can just completely decimate that down to a tiny fraction of. Is that a fair framing?
Yeah, I mean that's accurate. And then also I'll expand to say that it becomes necessary at scale. So right now, if you try to sync, it's annoying because we have so much history, but it is practical. You will eventually catch up. It's fine. It's just annoying because maybe I don't want to spend a long amount of time rebuilding my block state. If I'm a miner and my node crashes and it gets corrupted or whatever, I don't want to not be mining for a day. I don't want to not be mining at all, because every second I'm not mining, it's not cost effective. But in the future, when we are having massive blocks and we're having this massive history, I mean, it doesn't even have to have massive blocks. Like if you just take Bitcoin Cash 10 years from now at the current level of usage, it's still going to take roughly twice as long to sync. And that eventually becomes not practical. And that's why UTXO commitments at scale become a requirement, because to have new nodes enter the network, they're going to have to be able to practically validate the state and get to a valid state. And if the valid state requires, terabytes and terabytes of time or data and weeks worth of time, that doesn't become practical anymore. I mean, that's not even a Bitcoin Cash specific problem. That is any blockchain's problem. Is blockchains are immutable. So if you want to rebuild the state without some kind of checkpoint, it's going to take a linear additional amount of time to get there. So that's why commitments become a requirement. I think that's kind of like the emphasis that I want to get at, is if we really do want to scale for an infinity amount of time, commitments become a requirement.
So
Sorry. I want to elaborate on this a bit. In that you would this already exists in some small scale today, but it will get worse. Which is that if you don't have this commitment mechanism going on, people are gonna find ways around it, and you're not gonna like it. The reason I say that is that, well, what happens if you don't have UTXO commitments and don't have a relatively trustless way for people to fast sync? What happens is that, well, miners and exchanges are not gonna like that. Oh, my node crashed. I will have to. My node crashed. The hard drive is broken. I will have to spend a day catching up, and in the future it might be okay. I will have to spend weeks catching up. That is already kind of the case in the pre-commitment Ethereum. So what happens is that they're not going to go that route. They're going to say, okay, I will instead grab a trusted copy of a UTXO or the blockchain. Who should I grab it from? Okay, maybe this guy Josh Green is trustworthy. I'm going to grab it from Josh Green. And then over time, everyone starts grabbing blockchain states from Josh Green. Everyone syncs from him. And he becomes a one point of failure, and your blockchain becomes more and more fragile as things become more and more trusted, just like we have seen in some other solutions where non-custodial is very difficult to use, and so custodial solutions and trusted solutions becomes the norm. We don't want that to happen. We want people to have easy ways to do things as trustlessly as possible. And so, this is kind of the context of what will happen if this is not done before massive scale hits us in the face.
So
Sorry,
we already have taken the first steps towards that world. If you look at most nodes out there, they default with some assume valid for some part of the block history, so they can skip the signature validation, arguing that they're far enough down in history, therefore they must be valid. And this is part of like calculating the UTXO state. And if they're skipping on the validation rules there in normal node software shipped to people today, that behavior, we should expect to see more of it as the costs simply go up. I'll also make a point that there has been multiple miners who have lost money from making blocks with invalid things in them because they assume things to have been valid. And so, yeah, it's absolutely a certain outcome that if we do not trustlessly solve the initial, like, how do I join the network, then people are going to trustfully solve it for us, and that's a bad outcome.
I want to pile on to this from completely different angle. Yes, I think those are all valid. And then coming from an angle of a lot of people who have maybe been listening to what I'll call the wrong people for the last several years, they may think, oh no, these giant nodes are so dangerous, it's going to destroy decentralization. And this is one of the most beautiful things about Bitcoin Cash, that as Uname says, often it's the practical Bitcoin. And in this case, what that means is we've always known that giant blocks and an unrestricted, ridiculous amount of data, network activity, and so forth is actually bad. And this is the scaling, right? This is where, okay, we knew that a long time ago, but we also knew that there's solutions to it, the UTXO state, managing the UTXO state and commitments. So these things have been known for a long time. It's just that we're actually doing them and we're making them happen so that we can scale practically along with technology. As Josh said, as demand grows, we can grow. And so we're kind of the Goldie Bear, the what are they called? The Goldilocks and the Three Bears, right? It's not too big, it's not crazy and stupid, and takes so much resources that you end up with just one node that runs the whole network, because that's ridiculous and that's completely not decentralized at all, and it ends up failing to be a permissionless network that way. And it's also not some kind of ridiculous small block is a good per se type of approach to things, where you want everyone to be able to run a node just for the sake of it. And I think the way that we're approaching it will lead to a huge number of people being able to run nodes, an absolutely huge number of them, if they want to, because they're going to be engineered in a practical way to work within reasonable parameters. So I don't know. I don't even know if I said that very well, but I love Bitcoin Cash and how it has this practical approach to things. So what's the state, Josh, of FastSync and UTXO commitments?
I know, we have that chip out, and that, to my knowledge, has gotten some good responses. There was one criticism that I'm aware of from Flowy, from Tom, and I think it was a fair criticism. And it's also a great segue. But it's basically the question of, well, if every node eventually is a fast sync node, then how do we serve SPV wallets or Electrum wallets? Because we have to be able to prove to the wallets that those UTXOs that we gave them were mined. And with a fast sync node, you could potentially, or by default, you don't really have that ability to prove to the wallets that those UTXOs came from a mined transaction.
Is that right, yeah, though? Whenever I hear that, I always just think like a cache invalidation type thing. Like, okay, it's not in your cache, so go get it.
Well, it kind of is, yeah. So like SPV is a very flawed implementation. Like, you can, depending on how you do it, you can really just lie to SPV nodes pretty maliciously. That came up when we were building our SPV wallet for Dublin a while ago. And like, it was very difficult for us to feel confident that what they were getting, like what users would be getting, was something that can't be lied to. Now there's ways to prove it, right? You can, like, the traditional SPV sync is you request a Merkle block for every block, and that Merkle block is a special kind of block that proves that the UTXO that you have was actually mined in a block, and then you take that Merkle block and make sure that that is a real header that exists in your chain, and therefore you know that you haven't gotten lied to. There's still ways technically to lie to the users by like omission, by basically like having the SPV wallet say, hey, fellow node on the network, give me all my UTXOs. And then they're like, nah, you don't have any, dog. You're poor. And like that may not be true. And that problem, to my knowledge, hasn't been solved yet. but at least you solved basically by just preventing a Sybil attack by connecting to multiple peers and asking multiple peers for the same information and making sure that everyone isn't lying to you. So that's the best defense to that attack. But without Merkle blocks, you could basically be fed a UTXO that isn't real, and you don't really know. So that's where I think Tom's coming from. Is Tom saying that if we don't have the history, like the Merkle block, like if we don't have the history, then we can't build the Merkle block for the UTXOs. And if we can't build the Merkle block for the UTXOs, then we have a bunch of SPV wallets, including Electrum, that can be lied to. And that's not a great end term state.
I see. So going out to fetch that, whatever's missing is a completely non-trivial when you're trying to make a whole Merkle tree. Okay.
Yeah. So the way that works, right? A Merkle block is so say you have a UTXO and it's some transaction in a block, and what you'll do is you basically say, okay, well, I know that this UTXO is yours. So what I'm going to do is I'm going to send you that transaction, and then I'm also going to send you all of the other hashes of transactions that, when hashed together in a tree, form the Merkle root in the block header. So that's what the Merkle root is doing whenever we mine a block. Is that's basically the topmost hash that contained all of your transactions in that block. So then the SPV wallet can say, oh, okay, well, you gave me my transaction, I can calculate its hash, and now with all of these other like sibling basically hashes, I can rehash the values myself and verify that hash is the Merkle root in the block that was mined 2 years ago. So therefore I know that this transaction is real and wasn't just made up. Does that make sense?
Right. Yeah, and then if you don't have all of those siblings that you need, if they're not in the UTXO state, then okay, you can't verify it anymore. That's the point.
Yeah. You can't prove to an SPV wallet that transaction's there. So I was up really late one night for reasons I just couldn't sleep, and I was like trying to think about this problem. And I think the kind of cool idea that we came up with was just via brainstorm. This is super half-baked. I think it will work, but I think it's probably the next step in actually answering Tom's long-term concern. So again, to emphasize things with Tom's kind of like rebuttal, he's not here, so I hope I'm doing him justice. Is right now in the current state of Bitcoin Cash, his concern is, it's a concern. It's valid, and plenty of nodes have the history. We're not really not being able to solve this problem. For the long term, though, assuming the assumption that most or all nodes are running fast sync, then his concern's very real. I mean, then we can't really prove to SPV wallets, at least without a different mechanism. Without SPV, right? Maybe we have to get rid of SPV and we do some other mechanism or something like that. But I think that's a valid point. I don't think that necessarily excludes commitments from being successful. It just means that we also should probably try to answer that question. Go ahead.
Yeah, so for me, the outcome that every single node in existence is going to not have the history is it's a theoretical fiction piece. Fast sync does not prevent you from also syncing the history. And storage is much cheaper than calculation. So from my perspective, if you implement fast sync in a node that people want to use to provide SPV data for wallets, and people are going to want to have wallets, so they're going to want to have the information. People are not going to accept that, hey, I can't look up my history. It's just going to come the question of like, who has the incentive to take that action? And so to me, if you look at the network as a whole and you implement fast sync, then some of them who might be miner oriented, they will do fast sync and no history, because all they care about is being able to create valid block. Some of them won't do fast sync at all. Some of them will do fast sync and then start syncing the history backwards until they get to a point where they're no longer interested. And so I don't think the history is going away. I just think that the availability of that history is going to be contingent on demand. And
I agree with you. Yeah,
I don't mind buying per byte. Bytes are cheap. If I want my history from some node who are doing SPV proofs and doing me the service of making my wallet rock solid, fast, and convenient for me, I can pay them a couple cents a month. And on a large scale, that solves the situation and creates an incentive for people to host that infrastructure. So we just need to create demand, in my opinion.
I agree.
If I can jump in here,
yeah,
can talk about some interesting technical aspects here. So yeah, it's not that SPV wallets can be lied to. It's rather that nobody can provide the proof if nobody has the history. So the SPV wallets would basically stop working, which sucks. Yeah, because those are nice. It's lightweight. But there's yeah, so as far as like somebody would need to keep the history in order to keep a full index, like the Fulcrum server, for example. So they'd have to have a full blockchain, all the history, and they have to have an index of like every address, how it's been used in the past, because that's what wallets need. That's what wallets need to, like, for example, restore from seed, or if they've just not been online for a couple weeks and all the fast sync nodes have thrown away the history in the interim. So if they really want to catch up, that's what they want to get, is they want to see, like, for every address that I have, what's the entire history. So there does need to be like a Fulcrum server out there, basically. Yeah, but there's an interesting sort of intermediate thing that could be done, which is you can have fast sync nodes that or pruned nodes that keep an additional bit of data. They can partially discard blocks, basically. So they would keep all the transactions that have any outputs in the UTXO set, along with the proof that those transactions are in the blocks. So they would keep just the missing Merkle leaves of the Merkle tree. And those nodes would be able to provide SPV proofs for any current UTXOs. So they wouldn't need the full blockchain. They could also download this partial blockchain from other nodes and verify it, I believe. Yeah, so there's sort of an intermediate semi lightweight thing that could be done. I don't know how much it actually saves, but
yeah, no, that's literally the brainstorm that I had on Telegram 2 weeks ago. Yeah, no, it's a super good idea. And then also Bitcoin Autist, I think, had the this is again half-baked, Mark, so you tell me if you think this makes sense, because I think it does. So basically another micro optimization that you can do to just keeping the Merkle proofs for all of those UTXOs is you can actually do the SHA extension attack on the transaction hash. So you actually don't even need to keep the like the inputs. So like imagine you have a transaction that has 50 transaction inputs, and then you have one unspent output in that transaction. You can actually just take the single SHA of the first part of that transaction, and that will cover all of the inputs and all the metadata, and then you keep just the outputs of that transaction. Then when you went to go create the hash for that transaction, you just do the SHA-256 extension attack on it, and then hash it again. I thought that was really clever, and that could be an additional level of space saving.
It feels a little bit fragile, but yeah. So basically the problem here is that it's not that the SPV proofs are proof of a UTXO, they're actually proof of a transaction being in a block. So you might only be interested in one UTXO, but it might be like a big cash fusion transaction, which is enormous. And you'd have to download that full transaction. The node would have to keep that full transaction just for the sake of one unspent output. So if you could save a bit on that, that's sort of the optimization Josh is talking about there.
So something else that I realized because I was part of the brainstorming with Josh, in that, and I think I learned a lot from that conversation too, and managed to come up with something. I mean, maybe it's obvious to other people, but it was only obvious to me very recently. Um, which is that yes, there would be problems, and even if we solve them, there will be some additional fragilities with the existing SPV, with the existing type of SPV wallets. But another type of wallet that has been, you know, on in the works on and off for quite a while over the years, actually fits this regime a lot better, and that is the RPA, the reusable payment address slash stealth addresses regime. That type of wallet works a lot better with, you know, a any kind of tree like UTXO commitment. And the reason is because that type of wallet does not basically, you know, that type of wallet can operate history free. It doesn't need to go down the list of, okay, I got address at index 1, index 2, index 3, index 4, and index 200. It doesn't need to do that. It can always just ask the server, okay, give me the subset of the current UTXO that fits a certain criteria, and then okay, here we go, and then I filter the subset. You can always do that regardless of history. So that type of wallet actually fits this a- actual actually fits this new regime a lot better, and I was kind of happy to realize that.
All I know is whenever Uname says this might be obvious, I know I'm about to be in a lot of deep shit. Like I'm not gonna understand anything in the next like 5 minutes. But it sounds like you guys have there's a bunch of possibilities here, and there's ways to solve things. But where would you actually rate this, right? Because you don't want to get into the smoking hopium. We've seen where other chains go with that. What's kind of you guys rating on? Is this actually a solved problem? It's just a matter of implementing it, or do you think this is more like a no? We still have to think pretty deeply about this.
Before we go into that, I just want to emphasize that all of this fragility problems is not something that only happens when we implement UTXO commitments. If we don't have UTXO commitments and don't allow trustless fast sync, it will happen anyway. When we scale up to massive scale, like people would be less and less willing to host and provide history. That's just something that comes with scale. So I just want to get that out in case anyone mistakes it as, oh, my SPV wallet is going to stop working because UTXO commitments. No, that's not how it works. It's just a thing that happens when people are less willing to host history. And UTXO commitment offers people an alternative way out of this no history conundrum. Yeah, I just want to get it out there.
Yeah, that's totally right. I think so. Kind of coming a little bit full circle, and then also trying to answer your point, John. I think the version of UTXO, fast sync. I'll say the version of fast sync that was produced in that chip is, in my opinion, obvious. In my opinion, is a very good enough solution. It doesn't exclude other technologies from solving some of the other unresolved problems, but it does make our current situation and our current network better without necessarily excluding other possibilities in the future. And I think that, kind of summarizing it, I think I want to make sure that we as a network aren't looking at or falling into the trap of, perfect is the enemy of good kind of thing. It already solves a lot of problems that we have today in a very good enough way. And if we want to continue to solve some of those other problems, then we should. And I think we can. And that's actually kind of what that brainstorming was about. I mean, I don't want to derail us, so I'm not going to expand on it too much, at least in the second. But also kind of to Uname's point, SPV as a validation protocol kind of sucks. It sucks a lot, especially for nodes. And I think at scale it becomes impractical, at least the way that we have it implemented. So that in itself isn't really a good argument to not proceed with fast sync or UTXO commitments, in my opinion. So I think as far as where we're at,
there's some kind of replacement for SPV, like for example, something based on just a chain of block headers, like you don't have to have anything at all but the block header or the commitment, or
I don't know. That's not necessarily what I was saying. I mean, so basically, like if you look at traditional SPV, what you actually do as a wallet is you ask the node to provide a Merkle block, and then calculating that Merkle block is expensive for that node to do. So it's not very scalable. If you have 1 million users and you only have 1,000 nodes or something like that, like each node is going to be calculating a Merkle block for each user, because they're all going to be unique, because you're not serving all the UTXOs to the wallet. You're only serving the UTXOs that belong potentially to that wallet through the Merkle block. So it's not like, I calculated the Merkle block once and now I don't ever have to worry about it again. That's not how SPV is actually done. The alternative is what I think Mark was talking about a second ago, which is how Electrum does it. You have an index, and you basically, Electrum's like, here are my script hashes. Give me all of my UTXOs and then the proofs that those are real. And then it uses the index to then be smart about building the correct Merkle block. Instead of linearly traversing the whole blockchain of 800,000 things looking for UTXOs. So traditional SPV doesn't scale, is what I was really getting at. Is there a better alternative? Not that I know of yet, without a protocol change. But I am not convinced that we haven't spent a significant amount of brain power trying to solve that problem. I think there's lots of room to
if you
improve.
keep all the requirements. Like one of them notably is that you want to sync a standard HD wallet from seed, and hence will want all the history. Like there are ways around. The ways around that would typically involve radically changing the requirements.
Yeah, technically you don't actually need history for a wallet. Like if you didn't care that 5 years ago you restored from seed, and then 5 years ago this one address did the one thing, and that UTXO is gone. Like if you don't care about that, there are things you can do to have an SPV wallet work, but it would require changes to the SPV wallets. That's for sure. They don't like not having the full history the way they're currently written.
Yeah, and I think that's what the conversation should become, is let's look at wallet software. At least, I mean, personally, I think we should start looking at that now. I think the conversation, or the retort was brought up with UTXO commitments of, well, what about SPV? And I think really that conversation is, well, what really about wallets at scale is really the question there. I'm still, again, not convinced that the chips version of fast sync is a bad thing, especially because the chip doesn't even doesn't even mandate that we do a commitment. It's just a option to facilitate and also to prove demand, so that we can justify an actual change in protocol by adding the commitment. But I think I think it's a good conversation. I think we should start talking about wallets at long-term scale. And if that means the type of UTXO commitment that we do is different, I'm all for it. Like I'm not married to the idea of the key hashing kind of algorithm that we have for. I think it's a great solution. I think it could work very well, but I'm also still thinking that we should talk about it more if there's more talking to be had. So I'm trying to answer your question, John, of where we're at. And I think my answer is, I want people to talk about it more. And I also want people to be realistic. And if their problems with it aren't realistic, then I think we should move forward with it.
Yeah, and just to provide some additional data points and context, the traditional SPV wallets, as I have last used them, they don't just suck. They don't just theoretically suck in the future. Like they already sucked. The last, you know, they already sucked several years ago. Even back in 2017, um, which was I think when I last touched BTC. um, that was when I used a SPV Android wallet, and it's just a horrible experience restoring your wallet. It just goes on trying to catch up, trying to do this, and it does so for a really long time. Electron Cash does it a lot faster, but it's still not a terribly pleasant experience, and it would, I can only imagine it to get worse. Yeah, but it would still remain a lot better than the quote unquote traditional SPV for a while. Yeah, some of this nastiness you can already observe today, not in some theoretical future.
Oh, I guess to clarify one thing, when I was saying SPV, I referred to the technical verification mechanism, which is also what Electron Cash does, like
Yes,
Electrum
yes.
style.
Yes.
But it's a good point that some people refer to when they say SPV, they refer to the Bitcoin protocol SPV, which is like I think it was from Corey Fields or something way back in the day. He wrote that, and I think they're even abandoning that on BTC because it's just not a good mechanism. Not many people use it anyways, and it's a burden on the nodes anyways. So, for the reason Josh said, which is you have to scrape through the whole blockchain. Yeah, it's just miserable. So, yeah, I guess what my hope is that the more Electrum style SPV can be adapted in the future, and it has better scalability anyways right now. Yeah.
That's great. This sounds like, I think you did answer the question, Josh, and everyone, but it sounds from a high level, it sounds like one of those dangerous situations where you've got to do something eventually, but you're not sure exactly what it is. And in those situations with technical decisions where you can't undo the decision, right? You can't go back, and that's how most consensus changes are, more or less. There's also a risk of doing something that later you're like, that was the wrong choice, right? We did the wrong thing. So yeah, Josh, you were saying this is a time for discussing, making sure to hash out all the possibilities and possibly just wait, right? See other things that can be done in the meantime. I don't know, but yeah, we'll have to be careful not to do any kind of premature decision making when we don't understand the picture completely yet.
I agree with that. I do. I think if we spent the next year or two, I'll pitch this as a if Josh Green controlled everything and the entire ecosystem / world, I would say let's spend the next year implementing the current version of Fast Sync, not its commitment component. In the meantime, concurrently talking about how can we make wallets better in the next 2 or 3 years? And then after that conversation, if the schema that we still have makes sense, then let's add it to the protocol and let's do whatever new innovations that we have for wallet usability. Let's do those as well. Let's make sure that the technological decisions that we make for facilitating better large-scale wallets, let's make sure that the commitments help that. Worst case scenario, they don't, and we have to come up with something different, but that's not a deal breaker. And I think, I think that would be the best path forward. We're still getting incremental progress. We're still not stalemating in the face of uncertainty. And we're also not rushing a decision that doesn't need to be rushed. There's really no current reason that I'm aware of that Bitcoin Cash is going to break if we don't get UTXO commitments in the next year or 2 or 3. Like I don't necessarily see that coming, but I also don't want us to be grossly underprepared for when that does happen. So that's kind of my stance
Yeah,
on it.
Absolutely. We can't be flat-footed.
The more immediate problem is that my Cash Fusion wallet has 200,000 transactions, and it's gonna break anytime if nobody jumps on Electron Cash like yesterday. So yeah, Mark, please come and fix things.
We're just gonna make a poster
that
of
would be
you,
a
man.
great that would be a great situation where you're like, I don't care about this wallet's history.
Exactly.
Please just pay attention to what's happening now. Yeah, exactly
This
the
is-
scenario.
This is Uname. Don't be like Uname. Right? Yeah, Joe. So to the point about the state of it, that all sounds correct. And I just wanted to add one more thing, like the general context of it. I absolutely love it, and I'm so happy that Bitcoin Cash ecosystem is doing these multi-year thought processes and multi-year decision-making processes. The chip process has, I think, it has been instrumental in making that possible. And it's amazing to see what we've got going, right? The chips that have gone into Bitcoin Cash have been, I mean, some of them were conceived of and implemented quickly, but for the most part, these are all things that have been years in discussion and debate and bike shedding and so forth to get it into a very good state. Because yeah, once you make some of these decisions, you can't unmake them. So I've been very happy with how peaceful and productive and constructive people have been across multiple years working together, even with sometimes, very different opinions about how things should be done. It still ends up working out in the end. I should give praise again to Bitcoin Cash Artist, who's been kind of a master of that, at getting things to move forward and not getting exasperated with all the different people who jump in and have their opinion, and just like a steel trap, just taking it all in and incorporating everything that makes sense and responding to everything that doesn't make sense. Anyway,
I also agree with
that's
that.
great.
Like the poor, guy or whoever or whatever he is, like he was talking about he asked me to review the adaptive block size chip. And one of the things that I noticed is that it relies on an intermediate calculation that is larger than assigned long in Java. And I was like, oh, that sucks because, now we have to do X, Y, and Z. I was like, is there any way that we can cap the intermediate value and also the result so that we don't have to worry about unsigned longs because Java just doesn't have them because Java's Java. And like he spent like 2 days trying to figure out like how to do it and all this other stuff. And like, I think he took it back to BCHN or somebody else as well. And they're like, well, we can, but it doesn't really seem worth it. And at the end, the point that I was really trying to make is if we can, that would be convenient. I'm not saying that I'm not going to approve of this algorithm just because we have to use the big number equivalent in Java instead of using the unsigned long because it's less performant. So like mediating between so many different implementations and stakeholders and everything like that is not a job that I envy. So I totally appreciate him doing that.
Hell yeah. Thanks, Bitcoin Cash Artist, wherever you are out there. All right. Excellent. So yeah, is there anything before I don't know, well, we should probably wrap up, but I'm totally happy to just keep going for about 4 more hours. But does anybody have to jump off now, or could we keep going for a bit? I have a bunch of other things to ask you guys about.
Yeah, I think I'll get going soon if there's not anything else.
Yeah, right. Yeah, feel free, of course, to jump off anytime. If anybody in the audience had any questions for Mark before he goes, throw it up on Twitter or send it to me on DM or something like that. Is anybody else going to jump off right now? What I was hoping to talk about was a little bit about Cash Fusion, just a little bit, because that's been a topic recently. And then any other specific scaling points that you think we need to work on that we haven't mentioned so far, just to kind of round out, make sure we've covered a lot of ground at a high level on scaling.
Before Mark leaves, I have a question for him, if he's got time.
Sure, go ahead.
Mark, why are you actively ignoring me on Telegram?
I told him to. No.
Yeah, I have like notifications off for everybody, so
I figured. I'm just giving you hell.
no, I replied to your last message, so okay. Yeah.
No, you probably did. And
Yeah.
usually when I message you, it's more of like a social, like, "Hey, how are you?" It's not like like you name where I'm like, "Hey, get to work, Mark." What the hell?
No, he doesn't do that. No.
I do that, but sometimes, only sometimes.
Yeah.
Well, it is good to see you, Mark. I mean, I am happy that you still
sure.
exist, and I'm happy that you're here. So message me anytime.
Regarding Cash Fusion, though, if that's what you want to talk about next, if there's something you want to know quickly,
I did
like
want to know.
why is
Yeah.
Cash Fusion doing this or that? I can try to explain that if I remember. There are lots of weird decisions I made that I thought about very deeply, and I didn't probably explain very well.
No, absolutely. There's a lot of things like that where the longer I look at Cash Fusion and it works and the way the settings work, and I'm like, why doesn't it do this? And then if I think about it long enough, I'm like, yeah, there's probably a good reason for that. but no, what I wanted to ask was, having made it and it's been used an incredible amount. It's done a huge job that I think everybody appreciates so much. But having made that, for the most part, that was mostly you. And then having had some time away from it, I'm sure you've thought about it occasionally. Like, what are your thoughts on where you wish it would go? Whether you're doing it or not. Like, what are your thoughts on what you think needs to be done on it? Is it like analysis or some kind of experimentation, or is it further development of the protocol, or is it just tooling, or what kind of things have you thought you wish you could see or you would see?
Yeah, so when I stopped working on Cash Fusion, like there were lots of ideas I had about protocol improvements that were somewhat minor things here and there. So I had a Cash Fusion 2.0 planned out, and it's sketched out, but yeah, it's been a while since I thought of those things. One thing I did wish Cash Fusion had a little bit more anonymity in terms of network, that people could exclusively contact the server over Tor, and that would be somehow working well without exposing it to just being like DDoSed. Yeah, I could never really think of a way to make that work aside from having people like have to purchase subscriptions and then get like lose their like $5 or whatever if they misbehave, something like that. And that seems to open up a whole nother kind of worms for the server operators, accepting money and things like that. I hope somebody does analysis of Cash Fusion from like the white hat perspective before somebody starts analyzing it maliciously, let's just say. Because there might be some practical problems with the way that people are spending their coins after they use Cash Fusion and ruining the anonymity for everybody. Perhaps
there's definitely that going on.
Yeah.
No doubt.
Perhaps we should have tried to get larger fusions happening from the get-go at this at the price of having fewer of them and having to wait longer. Yeah, there's just lots of tiny things, but
what was the big idea of two things. Did you ever see the Red Team site where the guy did some
Nope. No,
I don't
never
think he
heard
did
of it.
statistical analysis of it,
Yeah.
but he is a kind of statistical analysis guy, and he started
Okay.
off doing more of like a technical analysis and collection of data. So it shows, how many coins are descended from Cash Fusion of all the BCH and then all the coins, on a coin basis and on a BCH amount basis, how much descends from Coin Fusion. He also has a live viewer of here's the latest Fusion transactions, and you can see like all these inputs and all the outputs. You can kind of look at them and see what they look like.
Yeah, I've not seen that. I did hear there's a certain number though for like descending from Cache Fusion that was quite high. That was impressive. But yeah, I have not seen anything else from that red
Let's
team.
see if I can dig that up. I'm looking for it right now. But what about the 2.0 that you were saying? Like, I think probably 99% of people here and listening won't be able to understand the details of it. Maybe, but is it possible to give like a high level of what you were thinking with it? That might not be possible. I don't know.
Yeah, there were some. It was some small changes. Like I wanted to allow more flexibility in terms of the way people could in the way wallets could participate. Like right now, you can have up to 23 things that you are involved in a transaction, like inputs or outputs, and that didn't have to be a fixed number. That for everybody involved in the transaction, that could be flexible. Trying to remember if there's something else. It's been a while since I looked at that. But yeah, I started working on coding it, and I never really got anywhere with it, so sort of lost that. But yeah, I think Cache Fusion could be a bit better. I could never really think of anything like a major overhaul though that would make it like super better. So yeah,
because it's already super better. Thank you very much for
Yeah.
making Cache Fusion.
At least as far as the protocol, as far as the like the way it's done in Electron Cache, for example, which so I developed the protocol and I also made the Electron Cache implementation that people are using, and that has some warts in it, and some features that would be nice to have, for example, in the imaginary username situation, having the giant wallet. It would be nice if he could seamlessly transition to a new wallet, just to not have to have that huge history. So start a new Cache Fusion wallet and have it use up the coins from the old wallet. Let's say.
I would like
and
that.
again,
Yeah.
Just to give some context, it's just this situation of having a really huge wallet is just not. It's not just me being a freak who likes Cache Fusion, although I do. Having this is actually a natural consequence of attempting to use Cache Fusion with the best UX. So what I did to get to this point is basically, okay, you start with a wallet, you start with a daily driver wallet, you use it every day, you have some coins in it, and then you turn on Cache Fusion, and then you just forget about it. You just forget about it. You keep using it, keeps using it, and then every day it consumes like 10 cents or some maybe some 50 cents, like a small amount to do Cache Fusions, which I don't care about. But I can stop worrying about it. I don't need to turn it on and off. I don't need to shut off my computer. That is like that is an awesome UX until the wallet starts getting sluggish.
That was like what we were sort of imagining that people should be able to do, is like have Cache Fusion going in the background, not using too much money. Ideally, you'd want it to be customizable by people how much they want to participate, but at the same time, you don't want that variability in behaviors to let people be profiled. That's just a little aside in terms of the way people are fusing affects things. But that was the hope, that people could do that sort of thing, and it's definitely unfortunate that you're getting punished by doing that.
But my hope is that since I'm probably like in the top 0.01% of Cache Fusion users who are getting into who's getting into dangerous category, I can provide the motivation to work on this, and then the other 99.9% of people can benefit from work, right? So
right. Yeah.
So Mark, before you have to go, I wanted to mention two things. One is just while you're here, I wanted to say, like I was joking about, it's already a better solution or whatever, but I really do think the Cache Fusion and its availability and its ease of use today already on Bitcoin Cash is a real superpower that is completely underappreciated by the whole of crypto.
That was great to hear.
There's nothing like it in crypto, right? Like you can just sit there and for cents a day have an incredible amount of privacy. So that's huge, and really appreciate you and the people that have worked on it. And then the second thing is that I'm not sure if you're aware, but there's a wallet called Stack Wallet, and Stack Wallet is a mobile wallet that supports several coins. But yeah, they're going to add Cash Fusion. They're in the process of fixing up the release, and they're going to have it at some point in the near future. So you'll be able to do fusions on mobile, which has its own difficulties. You know, you have to like leave it there because OSs don't allow background processes.
Oh, yes. I remember going through a lot of these discussions regarding another wallet that was mobile, and they were thinking of doing Cash Fusion. It's like, man, this is going to be tough. Like just the way these mobile OSs restrict your background behavior. It's a real issue. So I wish them luck with getting that working well.
Yeah, I think the trick is you don't get to run it in the background. I think that's the trick. But yeah, so it's coming out. It's spreading. It's going to appear in other places.
So here's another underappreciated feature: simply coin consolidation. At GP, we do a lot of contract, which gives very small amount of fees. So we end up with a bunch of coins. And having a privacy-focused way to consolidate all those coins, to keep the UTXO set from growing unnecessarily, and to keep the privacy of the customers, Cash Fusion seems to be working out really well for that purpose as well.
Yeah, I wish that was a little bit better. Specifically, the way it would have been nice if Electron Cash would keep track of like how private it thinks coins are, and try to, if you're doing this coin consolidation thing, if it would try to mix them in gently rather than grabbing too many at once. I think that would be better for the privacy aspect, because there can be an issue where it just like consolidates a bunch of coins that you've received. And it's sort of a giveaway that those belong to one person, depending on the situation. But yeah,
there's a lot of things. The longer you use it, you look at it and you're like, well, it should do this, and it should have this little thing that it does, and it should optimize that way, and it shouldn't do that, and it should make sure to remember this. Yeah, there's a lot of details.
Those things are definitely those, like, those like last 20% of things takes 5 times the amount of time. So
right. Right. All right.
It's a little bit better than a prototype is what I developed, basically.
It's a very valuable prototype.
Yeah.
Very valuable, a little bit better than a prototype. So thank you so much. And obviously you're welcome to hang around. I just want to ask if there's anything else you guys want to talk about for scaling. Like if there's any other things that we haven't covered that you think should be, get a quick mention. Mark, if you want to say before you go, or if you need to take off, whatever. So yeah, let's go ahead. Josh, was there anything else you wanted to bring up on scaling that's kind of come to mind during the conversation?
No, I think we hit all the top items for scaling.
Wait, we haven't even got to the cash token stuff.
So I actually have a scaling related question that Josh might be able to provide insight on.
Yeah, go ahead.
So as the blocks grow, we assume that more different persons are going to start using it, and the UTXO set is going to grow. In the end, we're going to have pretty large mempools, and in order to keep those synchronized so that different nodes see the same thing when they determine whether a transaction is valid or not, we might need to do further work in that area. Do you have any opinions on how one should, as a node developer, approach that. Like I know Bitcoin Unlimited did a bunch of work on the graphene protocol, and as part of that, they were looking into using some parts of it just to do mempool synchronization in the background, even though it wouldn't be used specifically for block transmission.
That is a wonderful topic because, I mean, basically, thinking out loud right now, transactions are sent node to node via like the Gossip protocol, which is super efficient. It's very chatty, per the name. And I mean, yeah, but I mean, I don't know off the top of my head, to be perfectly honest. I haven't spent a lot of my brain power recently thinking about mempool synchronization. I do agree that it is very valuable for zero conf, and also just making sure that chain transactions in general are getting into blocks appropriately without having to rebroadcast, etc. I don't have anything off the top of my head for synchronizing that, to be perfectly honest. But mostly it's just because I haven't thought about it recently enough. Yeah. Sorry, I don't have anything more on that right now, at least.
No worries. There's a couple of years left before it becomes critical.
Yeah. I mean, it's a fun problem to think about. Totally. I mean, also just the peer-to-peer protocol for Bitcoin nodes in general is not my favorite, to say the least. So, and the cool thing with it though is it doesn't necessarily require, despite being a protocol, it doesn't require like the block level protocol to change in order for us to do better. So there's less of like a momentum holding us back from getting creative and trying to solve things in a better way. So from that perspective, it's nice. But no, I don't have anything off the top of my head for mempool synchronization. I mean, Mark might. I don't know if he does.
Yeah, I was never really into that side of things. But yeah, as Josh says, it's not, the protocol is not actually Bitcoin. Ironically, Bitcoin is really the blockchain. So you could, in theory, do away with the entire protocol. It would be a lot of work, but it wouldn't really change things on a consensus level, which is kind of funny. Yeah.
I'm actually thinking about things now because it's an interesting problem, Jonathan. So like what is the problem that you're foreseeing that I should try to like solve for? So like what you're saying is, as we're getting transactions per second that are higher than what we're looking at, are you concerned with like the chaining of things, or just the concurrency of transactions in general? Because I mean, like in theory, as long as you can accept the transactions into your mempool fast enough, with the Gossip protocol, you should be relatively synced unless you have like a weird or bad like peer network, like, right? Like if you have like one peer, right, then you're obviously not great. Or if you have 8 peers and they're all like very close in proximity, like from a network perspective, not necessarily like a locale perspective, but if they are also not well connected, then you're more likely to not see transactions, and then you might get surprised when a new block comes in. But even then, once a new block comes in theory, you should be fixing that. Yeah, I'm trying to figure out like what specifically you're trying to get at.
Yeah, I don't have a specific thing to get at. I know there's been a lot of discussions in the past about how to improve block propagation, and it's just something that I picked up while reading on how BU did it with graphene and how they got to that solution.
Yeah.
Or except and why that solution hasn't made it everywhere else and so on. And it's fascinating to me because that graphene is intended to do better at a higher scale than they are today, and so there might be something to learn from there. And yeah, mempools are going to get larger, so whatever that implies or whatever problems we get from that is something to think about as we grow.
Yeah, so I mean, for other users, or I mean, like other people here in the chat, like if I recall correctly, for graphene, it was not necessarily like, I think it had two components. Actually, no, I think it just had one component, but it was reliant on another one. So basically, if I recall correctly, and this was, I think, at least 1.5 years ago, if not 2 years ago, that I remember looking at graphene. It's a block propagation that relies on the fact that most of the transactions that are going to be in that block, you should have already seen. So the actual data transfer from node to node can be cropped down significantly by basically just enumerating the transactions that are in that hash. Because currently, right now, if you transmit a block, depending on your node implementation and all the other things that we have, because there's also thin blocks and stuff like that, you submit the whole block to all your peers, and like that's a lot of redundant data. It's basically capturing 10 minutes of data and then sending it off in one single blast, even though if you've been on the line for the last 10 minutes, you've probably seen 99% of that data already. So it's super redundant. So really what graphene is doing is it's saying, well, if you've been online for the last 10 minutes and all of our mempools are in sync, then the block that we're going to send you is just these. And it's just like the inventory, basically. And then the node itself can piece together that block itself. It's a clever idea. I think it is a good concept for sure. Like, I mean, like, whether or not graphene specifically is the right answer, I have no opinion on. But the concept of, if you've been online for the last 10 minutes, we shouldn't have to transmit 10 minutes worth of data in 10 seconds just so you can validate that the next block has happened. So that optimization definitely should happen. It does require, though, that most of those transactions that are in that block you've already seen. The reason for that is because if you get this inventory of transactions that are in this block, and a lot of those items weren't in your mempool, now you have to do a whole nother round trip of communication with that node in order to request the transactions that you were missing, and just to rebuild the block. And that can have some problems, and at some point has a trade-off of like, well, were all of these multiple round trips even faster than just sending the whole block in the first place? And I think that's probably what you're like thinking of, Jonathan, is like, that's why mempool synchronization matters, because that's when we can get that benefit. I kind of also recall that.
Yeah, so the larger.
Yeah, go ahead.
Yeah, the larger the block gets and the larger the mempool gets, the more data is going to need to be compressed into as short time as technically possible. And set reconciliation, just providing the missing part of the set on the other side, is a potentially better way to do it. I know that it was rejected by Amori from Bitcoin ABC on the premise that it had one run tip too many. And I think it might have been a acceptable or good thing to like, we didn't have a block propagation problem that was super urgent to resolve at that time. And so, yeah, being extra picky might have been sensible. I know that graphene then went on and like got into real world production and got into more significant testing. And when they got to version 2 of graphene, they had essentially started implementing this in the background mempool synchronization feature, so that they wouldn't get any errors when it was time to propagate the block, and therefore didn't need to do that extra round trip in the end. Anyway,
yeah, I mean, that makes sense. It seems congruent with what I remember.
Insight in the matter, because it's one of the things that I think we have enough information available today that we are going to fairly trivially solve it, and the solution for it does not require consensus changes.
Yeah.
I didn't consider it one of these things like, to get to 1 billion users, we need to do this. Something like that will happen along the way, and it's fine.
I mean, bringing this up again is 100% the right thing to bring up, per John's question, right? Like, thinking about scaling long term, right? It's basically like what we're optimizing for. If you're optimizing for speed, like your download, like your internet download speed or your upload speed, graphene is, I think, going to be very efficient from that, regardless of whether or not you have 1 or 2 extra round trips. Like I feel like your latency, which should be in the hundreds of milliseconds, should be faster than it takes to download a gig if we have a gigabyte block, right? Like that efficiency certainly is going to be worth a potential round trip. And I think that's actually a good point. And also too, like, it's not the actual block consensus level. So, whatever, when the need arises, if that actually becomes, when that actually becomes a need, adopting new technologies shouldn't be super prohibitive. And honestly, again, to my point of making sure that we're not flat-footed, I think the fact that BU has done that work is good, because when we have that problem and it's more relevant, we can say, hey, wait, what about graphene? Like, why aren't we using that? I also do forget how graphene differs from thin blocks, to be perfectly honest. And I forget which one's which, because I think there's also X-thin, and I got them all very confused, but that might be irrelevant for right now. But regardless, like, block propagation technology is 100% a part of scaling. So
it is. And I know there was also I can't recall the name now. There's a miner who did work on setting up an entirely new protocol that was supposed to be even better than graphene, utilizing information that transactions don't look so different from each other or something like that. I can't remember it.
The other Jonathan?
You one more time?
Jonathan Tumim? The other Jonathan?
Yeah, Tumim. Right. Do you remember what his name? His protocol was named and how it worked?
I thought it was X-Thin. Wasn't it X-Thin?
X-Thinner.
X-Thinner.
Yes.
Thinner. Because X-Thin wasn't confusing enough. Yeah, X-Thinner. You're right. That was too.
Let me ask a tangent question now, that before we get to the 6th or the 7th of these protocols. So tell me if I'm right or wrong, just in summary. We don't need to go into the depth, but remember, I think it was called Storm, and the concept of, I think that was right, the kind of intermediate blocks where you're making some pseudo commitments to mempool states along the way, and then there's this is like a consensus idea, right? Then there's some penalty to going against that kind of pseudo consensus.
Yeah.
Does that have anything at all to do with scaling, or is that just kind of tangent to the topic?
It can, depending on what kind of scaling you want. My understanding for that was, one, if the most important thing that you are benefiting from, or I'm sorry, if one of the very important things that you're benefiting from is mempool synchronization for instance, block propagation, having a miner come out of the blue and like have half of a gigabyte's worth of data that no one has seen before can be problematic. Usually the only person that they're shooting is themselves. But it's still at least a consideration. So that prevents that kind of tomfoolery from happening. It also helps the user experience know that the transaction that they've sent that hasn't been confirmed yet is better received than just like the 1 or 2 or 8 nodes that they have connected to their node. So it helps zero conf, which, depending on your definition of scaling, can also be beneficial, because you end up having like half confs and stuff like that. It's an interesting concept. I don't necessarily seeing it be currently like a fundamental step of scaling, at least with the demand that I see in our foreseeable future. But maybe I'm wrong. Maybe I'm not thinking of some clever thing that's coming up. I can leave it at that.
Yeah, so I really like the idea
that's great.
of making more use of the hashes that didn't result in a valid block. And there is, as Josh said, a lot of benefits to having these sub-blocks, but I never could find a way that they would fit into consensus rules in a way that was like satisfying to me. I always could point out and say like, this aspect looks kind of weird to me. Why would people do this? And most of the answers came down to incentives say they will or should, but yeah, I preferred something harder than like an expectation only based on that.
All right, cool. We've covered a lot. Let me ask one more thing. I've been reminded, Josh, that you mentioned something about cash tokens in the beginning and what you guys are working on. Is that something you can talk about, or is that part of the super secret project?
Well, I'll say that we are trying to do what we did for Dublin for another Ohio organization that uses cash tokens. But it's not confirmed, so I don't really necessarily like want to be like, hey, yeah, it's totally happening, guys. Get ready. You know what I mean? Like it's looking really good, is what I'll say. So we'll see. And I mean, I don't know. I mean, I think in general, though, the real sentiment that I want to get across is that there was the NFT craze where people were silly. I'll say silly generously.
Yes.
And like, cool, good job, I guess. But like but I mean, NFTs in general legitimately have a purpose. And now that we're kind of past the insanity of whatever the previous NFT phase was, I'm hoping / I'm seeing evidence of organizations and people looking at NFTs practically instead of like, oh, okay, well, cool, I own this image for, you know what I mean? Like this ridiculous thing where it's like all speculatory nonsense, like actually seeing NFTs for what NFTs really are / should be. And that conversation like those whisperings, right, are the general consensus among the common folk is good. You know what I mean? The fact that they're actually like familiar with even the letters NFT, like they may not know what they mean because it's a silly acronym, but like, you know, at least they get it. And it's the fact that BCH has something that can facilitate that now. Like it's a shame that Jason isn't here. Like the fact that BCH has that isn't SLP, I think is huge. And that's kind of what I'm talking about with the demand. Like let's focus on technologies that facilitate demand. Let's not also ignore scaling, but like, you know, if we were able to scale to terabyte blocks right now or something insane, like, okay, who cares? Like if we don't have enough transactions to fill them, then why? And I think that's what I'm getting at is like, let's keep in mind scaling. Let's still be responsible. Let's still be forward thinking. And let's do the technologies that make people want to use this technology, because if we don't have the demand, then what's it all for? So yeah, I mean that's kind of my point with the NFTs. I think that was a really smart move on our part, ours being BCH Collective. Like I think that is good. Let's continue to do those kinds of things. Let's add better wallet experiences. Let's respond to upcoming demands and technologies as they come up. Let's make sure that we're being relevant. That's all.
Yeah, we're graduating from the .com boom phase to the internet phase where you actually use it instead of just buying and selling it. Yeah. Right. Oh, one more question. I'm gonna ask one more question before I wrap up. See if I can stump you. What's your favorite demand generator on Bitcoin Cash today, and why is it BCH Bull?
Honestly, I mean, I'm going to disappoint you and not mention BCH Bull. I'm sorry, but I want you to talk about it. Honestly, my favorite silly feature of BCH right now is, it pains me to say because it is technically custodial, but being able to text someone BCH who doesn't have a wallet is, to me, the coolest adoption feature ever. I literally use it like at least once a week, where like at the Bitcoin, it's Bitcoin.com's thing. You can like create a text address, like a regular URL, and then you text it to someone, and then when they click the link, if they don't have the Bitcoin.com wallet, it brings them to the App Store, and then when they install it, it has the BCH that you sent to that link in it already. So you could basically be like,
Nice.
here's $5 of BCH. Have fun. Like, you don't have a wallet? Oh, okay. I don't have to go through like okay, well, download this wallet. Give me your address. No, that's not the right one. Okay. You know what I mean? Like, it's a one shot off thing. If they don't claim it, you can like take it back later if you want. Like, that to me is the biggest adoption thing that I can get, because it's a great way to send people money. I don't do Venmo. So like when I play a lot of hockey nowadays. So like if I'm having to pay someone back for ice time or, you know, some tape or whatever, I just text them some BCH, and then they get some. You know, it feels very reminiscent to the 2011 days where you know, yeah, you want some BCH or back then it was Bitcoin, right? Like, you want some Bitcoin? Oh, what's that? Let me tell you. You know what I mean? Like, that's cool. Like, that's the whole point of what we're doing. We want to be able to send people money without a third party intermediary. I mean, technically, the irony is that we're using Bitcoin.com, but it's still neat. Like, it's still cool. It's still functional. It gets the job done. And then they can become their own custodians once they receive it. It's perfect. So I don't know if that was your question, but that's
that's exactly what I was asking. No, I absolutely love that. Yeah, and I think that whole feature is based on I can't remember what he called it. There was a name they had for it, for the shareable links thing. Anyway, that was Roger's initiative. I'm pretty sure Roger's the one who pushed that and made sure that got out there. So I really appreciate that he's like, look, just make practical stuff that makes it easier to onboard and get people into permissionless money network. So I really appreciate that he pushed that out there on Bitcoin.com. I would love for him to be more engaged again today. So I hope he'll hear that at some point.
Yeah, sure. Me too. I mean, it's a perfect example of compromising perfect for good, right? Like, sure, it's technically mildly custodial. Don't send $1 million to the shareable link. But like, if you're just trying to onboard someone for $20, like, it is perfect. It is so convenient, so good. It solves all of the user experience problems that we encounter when we're trying to onboard a new user. It's a brilliant idea. And like I said, it's the best part of it is it's not perfect, but it is good enough.
Nice. That's a great answer. I'm glad you actually had an answer for that. Couldn't stump you. All right. I think we're good to wrap up. Is there anything you guys wanted to add before we close up?
Yeah, I was going to turn this around. Like, Josh, do you have any questions for us?
Yeah. What is Wallet Connect and why is it so cool? I've never heard of it until like 2 weeks ago.
Well, Wallet Connect isn't cool.
It isn't cool?
You can do cool things with it, right? That's fine. But essentially, Wallet Connect is a relay server. So you have a application on a website somewhere that sends a request to the wallet, to the relay server, and your wallet talks with the relay server to get that request. It's a transport protocol, more or less. So the cool is the thing you do with it. Wallet Connect itself isn't cool.
No, that's still cool. I mean, like the techno, like the relay, it's just a protocol is what you're sounding like. Is it like a WebSocket? Is that what it is?
No, it's an actual server that stores messages for offline. So it's a middleman. But okay. Let's put all that to the side, and I'll give you a better answer. You should talk with Jim. He's making a proposal for how to do cooler stuff with Wallet Connect than we're currently doing.
Okay.
That will also work outside of Wallet Connect.
Well, the thing that made it cool for me is someone in some Telegram was like, mint a cash token BCH Ninja thing. And I'm like, fucking fine. Like, all right, fine. And that was I forgot what. Well, I think I used Paytaka or something like that. I think maybe that was their announcement of that they integrated with BCH Ninja, and it was a cool experience. I had never actually seen that before, and I thought it made a lot of sense. And it solved some problems that I had previously just accepted as annoying. So I thought that was kind of neat. I don't know the history of it though, so I'm curious.
I'll say in a more positive frame. It's a good step, in my opinion.
I'll take that
towards where we need to end up. It's a good step, right? Because it starts it starts to separate the app and the user so that one side doesn't have to make all the decisions. I think it's a good step in that direction, but it has some very serious security.
That's what I was
and-
wondering. That's why I used a completely different wallet. I'm like, is this like one of those things where they're like, oh yeah, we'll craft this transaction for you. Don't worry.
Don't worry, buddy.
Don't worry,
That's
guy. We got this.
That's exactly the problem. Is that you still
that's
end up with
unfortunate.
some kind of blob, and you're like, do you want to do this? And,
And you don't know.
here's this
Yeah,
giant
really.
blob of stuff that you have no way to understand, and you're like, I guess so.
Not only do you
Right.
have no way of
Of course
understanding,
that's
you
how they
can't
solve
even know that it's presented properly from your wallet because your wallet does not
Yeah, you
understand
can't
it.
even know. So you have to. It ends up boiling down to trust of the app and trust of the DNS system, right? Not to censor you, not to interfere with you, to give you the right data. Your wallet isn't smart enough to understand what's going on, and so you don't have anybody on your team making good decisions.
That
But
makes
yeah,
it
it's
so
a good
sad. I
step.
thought it was gonna be so much cooler than that. I thought it was
Now,
gonna
what
be
Jim is
actually
working
solving
on
it that way.
makes it. Jim takes it one step further. The stuff that
Okay.
he's doing, because he uses the transport protocol to transport the templates of liboff that Jason has come up with, so that even though your wallet may not fully understand it, at least it has the possibility in the future to be like, oh wait, maybe we can look at this thing and
Right.
kind of break it down and start to present it to you and make decisions. So it puts
it's
the
kind of
wallet
like
in a
the-
position to make good decisions, even if it's being dumb today.
So it's kind of like the equivalent right now of like, here's this blob, just sign it, bro. Right? Is that what you're saying?
Yes.
Yeah, that's bad. That's very bad. That's
very
very,
bad.
very bad.
Yeah.
Right?
Well,
Yes, it's very bad. And it's also sign it with the same key that you've signed, the last 500 transactions
Oh,
that you
so
did.
yeah,
and
even
spent.
do the
it's absolutely
exposure
horrible.
attack.
But I'll say it again. It's not long now, right? A quarter from now, maybe, and you'll get to see something much better.
Okay, I like it. I'm excited. That makes me happy. I think I know what you're talking about, and I'm excited to see that then.
So it's going in the right direction, as long as we keep
good.
moving and
Good.
we don't get stuck on it.
Has anyone done a key exposure attack with the Wallet Connect?
I don't think so, but there's like absolutely no privacy. It's just like Ethereum when you work with these, right? Because you're using the same address for everything. So
Gross.
Yeah.
Well, okay. Anyone listening, if you want to break it, just have them sign the same thing twice with different nods.
Yes, very dangerous. Very, very dangerous. Which is exactly what happens with apps, right? Which is exactly what happens with an app that is naive, right? The app will send you, hey, sign this message with this nonce. And then the next time they send you, sign this message with this nonce. And it's like, that's okay, right? And it's like, no. That's not okay.
Oh, man. That's well, good. Come up with something better, because that ain't going to fly.
Yeah.
It was a good user experience, but that is a perfect example. It is not perfect, but it is also not good enough.
Right. Yeah. So we just got to keep moving, and that's fine. That's how everything is.
Yeah.
Yeah.
Anyway, thanks for having me, guys. It was fun.
Thanks so much for talking and teaching us about it, and teaching everybody about UTXO commitments, fast sync, and everything else going on. Look forward to hearing about something that may or may not be going on in Ohio.
Yeah, hopefully we'll probably know more in January. So.
Sweet. All right. Take care, man. It's good to talk with you.
Take care, guys.
All right.
Care.
All right, we're 2 hours in. It's a good time to call it quits.
Be gone.